So I might run around a little bit as well. The stage is so tiny, I tend to walk, so I might give some love to this part of the room and that part of the room sometime. How many of you remember the Cold War? And I feel the youngsters didn't put up their hands, I see. And the Iron Curtain, right? I used to live on the other side of that Iron Curtain. And my parents realized in the early 80s that the experiment hasn't really worked out. So they thought, well, let's go and jump to the other side of that wall. Not literally jump, but you know what I mean? So we moved from the east to the west, and we moved to another country that spoke English. We didn't speak English. And we used to live back in the east, we used to live in a 2-room apartment, 5 of us, a family of 5. Then we moved to a house in the west that had a backyard and a front yard. So what do you do when you get a house? You go and buy yourself a dog, right? So we got this cute little German shepherd called Oscar. And as you know, dogs are very messy and very energetic. And unlike cats, you have to kind of wash them quite often because they don't tend to look after themselves. So I remember my mother going to the shops and getting a shampoo for the dog. We came back from school and she says to me, this dog just hates water, right? It's like, just didn't like this bath at all. It was literally trying to jump out of its skin. I'm thinking, dogs, I mean, really, they don't mind water as much as cats, right? And so, but everything was revealed, you know, once we discovered what kind of shampoo she bought for the dog, right? So sometimes I think things maybe are not what they seem, even though those dogs don't look that distressed on the picture, right? So a mistake could have been made quite easily there, right? So my name is Mac Brawler. I'm part of Tableau team in Sydney, Australia. I've been with Tableau for almost 6 years now. I think I probably traveled the furthest, and Jason somewhere in the audience as well, as a speaker to this event. So just when I get over my jet lag, I'm going back. So over 6 years, like 4 of us when we started, under 6 years, should I say. There's probably about 100 people in that office now, so clearly something is going right. When I'm not doing sort of Tableau work and talking to people from stage or otherwise, I'm probably going to hang around the World Cup or something. I went to Russia last year. I took some photos. I like doing that too. It saves me some money on stock photographs. And if I'm not doing that, I'm probably finding some football data to viz about as well, and you find a whole lot of stuff around Tableau Public. And I did some visualizations before the World Cup. In fact, we had a conference in Sydney just before the World Cup with about 1,200 people, and we predicted using data that France was going to win. I'm still waiting for some monetary contribution from all those punters that were in the room, but they're not forthcoming somehow. So according to Gartner, by the year 2020, which is only a few, not that many months away, right? It's not even years, but just over a year. 80% of organizations, probably many like the ones represented in this room, would realize that data literacy is a critical skill and there's a major shortage of that skill in those organizations. So they'll be scrambling to try and roll out some educational programs to address that. Now, I know you guys are really the data people here, right? So you're probably not representative of the general population. So I'm thinking that most of you are probably on that journey already, or you're thinking about it, or you're educating yourself, or you're driving that change. So one thing is I hope you're not part of that 80%. So a few things in this presentation that I want to sort of address and hopefully you can take home with you. One is, because you're all data people, I want to kind of expand the definition of what data literacy is. Because sometimes we think about it as just a matter of understanding a chart and kind of that's where it ends. And I think it's much broader than that, and we need to maybe get the full picture. And the second part is for you to take something with you so that when you go back to the office and you're surrounded by people that are not geeking out on data like you do, they're not really that passionate about it. And we got to drag them along to say, look, this has so much value, and it's actually fun, and there's some interesting stuff here. And we all need to be skilled up on data literacy in order to make most of that data. So what is data literacy anyway, and why is there so much talk about it? Why should we care about it? I think it's very similar to the reading and writing skills, which had to kind of move beyond the scholars 100 years ago. And data literacy is sort of at this point now, I think, what is becoming probably one of the most important business skills that people need to have throughout the organization. Right? This is not about data scientists. This is not about technology. This is about everyone having this common language. I mean, consider for a second that if you had a library or again, some of the youngsters might not understand what I'm talking about here, or a bookshop full of the greatest books ever written, it wouldn't be that useful to you if you were illiterate, or if those books were written in a language that you don't understand. And until you can read that content and appreciate it, this would just be a library full of useless collection of inked pages, really, right? And I think the same is true. We talk a lot about how much data we're collecting. Someone always quotes these numbers, and it's just petabytes of stuff that we're storing somewhere. But again, if we don't have the language or the capabilities or the skills to make sense of it, we're going to end up with ones and zeros somewhere in the cloud. That won't be that useful. So look at some definitions here. Literacy, ability to derive information from the written word. That's kind of obvious. Sort of by extension, data literacy would be the ability to derive meaningful information from data. And I probably would like to add another little piece here, and argue with that data. Something that our politicians should probably take note of and use facts and things to make decisions and policies and so on. Now, this is still a very, kind of a shallow definition. It's a little too obvious. We need to expand on it. So let's put this idea to the test first. And we're going to talk about the weather for a second, or more specifically about weather forecasting. And I picked this because everyone in this room has a weather app. And it's probably the most commonly used app that you have on your phone. You probably look at it at least once a day. So let's look at a typical forecast. So this is what you might expect to see. Don't worry about the temperature. We will do the metric system education another day. I live in hope, that one day you guys are going to see the light. But we're going to focus on that number, which is the chance of rain. And it says 60%. So what does that really mean? It's a pretty simple question to ask. Well, it could be that it will rain 60% of the time. So the forecast is for the next 12 hours or 24 hours. Or it will rain in the 60% of the area. Now, some of you might know the answer. Some of you are probably Googling to find out what it is. Some of you don't care, maybe. But the answer is actually not as simple as it seems. Because if you go and look this up, and you look at the US National Weather Service, it's actually based on a formula that's shown here. It's the probability of precipitation, which is the confidence that it will rain, some percentage, and a percentage of the area that it will rain in. So in this example, 60% could mean that we have 100% confidence that it will rain in 60% of the area. So, you might be in that other 40% is not raining, so the bloody weatherman, right, didn't get it right again. Well, they kind of got it right. We just didn't understand what they meant. Or you could be 75% confidence, a lower confidence, but over a larger area. Well, the point I'm trying to make here is that I couldn't really find a simpler example, just a single number. But we still, probably, many people don't really understand what that means. So imagine if we're now looking at volumes of data, much more complex than just a single number. Clearly, we need some skills in order to interpret this. In this case, you probably need some kind of weather literacy to really see what's going on. So for me, this whole thing just boils down to this concept of being able to think in data. And what I mean by that is that we need to get to a point where data is part of everything you do at work, right? Probably in your personal life to some degree too. So when we're making decisions, data is part of that fabric, right? That's just how we do things. It isn't a little thing that sits on the side And we kind of consult it every now and then, and and someone says, well, just give us a table of numbers, just throw a chart in there so it looks pretty kind of thing. We want this to be really in the fabric of the way we work. And those of you that have ever had to learn another language will kind of appreciate this concept, because you probably remember when you were learning, say, English for me, in those early days, I was translating from Polish to English, and then things will come out kind of backwards and didn't really kind of work. But then a time came where I started thinking in English and dreaming in English, and it just all made sense, right? Kind of like driving your car. Remember, you had to work out all the pedals and things? You don't think about it now. So we want to get to a point, the more we use data, it just becomes this sort of second nature. Now, unfortunately, this is not exactly what's going on in the world of, corporate world at least. When I talk to customers, many of them, if not all of them, want to be data-driven, right? They want to use data to make decisions and use facts. But they're all struggling. They're not quite where they want to be. And there are examples of some companies out there that are obviously doing this right, and it's maybe the other sort of extreme. And two that come to mind would be like Uber or Airbnb. And I would call these pure data companies, because they wouldn't really exist without data. This is kind of beyond just using data as a decision-making process. And remember, those companies came about sort of during the GFC period. And this was the time people didn't have money to blow on holidays and travel around in taxis all day long, right? And these guys discovered that we could actually, using data, work out a very efficient and cost-effective way of linking those suppliers of those services to the consumers of those services, right? And without data, this just would not happen. Now, many of us are not in businesses like that, maybe, but we still want to use data to make decisions. And here's a sad statistic. It says that 52% of C-level executives dismiss data because they don't understand it. I'm not picking on C executives here, but this number is probably true in other areas. And I suppose if you go up to the politicians and governments, it might be even higher. And speaking about prime ministers and presidents, this is a global problem that we see every day. So why is that number so bad and so sad? Well, I got two kind of theories about this. The first one is a cultural challenge, which is probably the harder of the two. And I went, this isn't anything unique to our world. If we go back and look in history, and I picked the world of science and see how they sort of address some of these challenges. And there's a great quote here from Max Planck, theoretical physicist. I'm sure you're very familiar with his work. He got a Nobel Prize in 1918. And he had this quote that says, "A new scientific truth does not triumph by convincing its opponents and making them see the light, but rather because its opponents eventually die." Right? And a new generation then grows up that is familiar with this new scientific truth. So, in plain English, what he's saying is that science advances by a series of funerals, right? Sometimes we just give up convincing people or trying to, address these. And again, I'm not picking on like leadership teams and so on here, but if we going to succeed with data, this has to come from the top. That idea that they believe in data and they are communicating this to entire companies saying this is how we're going to do things, it needs to happen. If it doesn't happen, it's very hard to do it from bottom up. So, we just don't have the time to wait sometimes. Maybe it's a recruitment problem. I don't know, right? So that was the first challenge, which it's a cultural one, and it is sometimes not that easy to solve. Second one is around complexity, and I think as humans, we've got this tendency to overcomplicate things. I don't know, it's just naturally sort of comes to us, right? We keep piling things on. It's just so much easier to keep piling things on, and before you know it, they just way overcomplicated. And I've got some examples for you here. So I was saying earlier, I do take photos. These are not my best works here, but I've been photographing street signs around the world. This is a parking sign in Sydney. Here's one in Singapore. Here's one in Santa Monica, right? So This is clearly a global issue here, where these signs are just very difficult to understand, especially when you're driving in the car and trying to read them at the same time. And consider for a second that the only reason why they exist is to answer one simple question. Can I park my car here right now? That's it. There's no other reason other than, revenue-making thing. I don't know, but I'm assuming that that's not really the original intention. So why do these even exist? Because we just overcomplicated this whole thing. If we stood back from this and said, let's think about that one question. Could we reinvent this or reimagine this into a different solution that might just be much more applicable to solving that one problem? And here's an example. I see everybody's taking photos. You're going to get the slides. So my point here is that, yes, if the data is too complicated for you to make sense of it, then you will give up. I think humans are lazy also, in a good way. You wouldn't be wasting time trying to figure things out if there is an easier way for you to communicate that information. So let me show you an example. I might step down for that one. I'm going to do a Hans. They didn't tell me. All right, they didn't tell me to not walk there. Oh. Are there any questions? I can only hear you in the ear now. All right, I'll do it from up here, okay. Where were we? So I've got a couple of million rows of data on US fatalities on the roads. Given enough time and effort, you can go and figure something out. You can go look at that data and find something interesting. I decided to kind of dump it all into a single viz that looks something like that. Let me explain what it is. So at the top, you got days of the week. We start our weeks on Monday, as you can see there. And then you've got each little block is an hour of the day. And then you've got all the states down on the left. So clearly, as soon as this popped up, you kind of see straight away. People get pissed on Friday night, and then horrible things happen. They go drinking again on Saturday night, and again, things are not working out very well for them. But the more you look at this, you start seeing some other interesting things, and those in the front row can see Wyoming in the bottom row there. And anyone from Wyoming here that could explain what's going on down there? So I went digging around to find out what the hell's going on. And I uncovered a few things. Obviously, it's a big place. It's cold. There are mountains, few people. This is per 100,000 population. And I think there's only 100,000 people there. Apparently, the seatbelt laws are pretty lenient, or used to be lenient. So that was one of the reasons. And after the talk on yesterday, a gentleman came to me and he gave me a couple of other reasons why. He said, apparently the driving age is like 14 or something, right? Well, and apparently in the past, your drinking age there was also lower, 18. Well, that's like the rest of the world, but now it's 21. People carding me, should I feel, I don't know, I'm 50, all right? Like, seriously. So what I'm trying to say here is that suddenly there's this conversation that I'm having around data because there are questions that I did not see I even imagined to have. I mean, a few other things you can see. It seems people start drinking earlier in Mississippi and New Mexico there as well, right? So if we presented information in an easier way, and we at Tableau, this is exactly what we do, I think more and more people will be able to make more and more sense of it. But again, this is sort of on the surface what data literacy is about. So a few little points, and a lot of this is in parallel with what literacy is. So clearly reading and writing, or reading and understanding is an obvious thing that we know. And in our world, it is the ability to read and understand charts, okay? But I think we need to go beyond that. We need to also probably think about the data. Is that data relevant? Is that data correct? Is that part of data literacy? Should we just be taking these charts at face value and believing what you see? I think we need to ask more questions. So, but then when you think about literacy, in the early days, very few people were writing stuff, right? Monks was kind of scribing things it took very long time, and very few people could read it because literacy was very low. Then the printing press was invented in 1439, and we could automate the process of creating and printing lots of books. Very similar to the world of report factories, right? Few people are creating content, distributing it to the masses, and obviously more and more people were able to read as the literacy went up. So that obviously went quite, improved a lot by the number of books we had. But the problem was there were still very few people writing content. There were very few ideas that are being presented to the masses. The magic happened later when more people started writing, because now they were putting their own ideas in print and distributing them to a wider audience. And I think we are kind of on the cusp of that kind of work. And by the way, you can just see that chart. I should mention that hockey stick is the number of individual titles, which sort of by proxy would be number of authors that are creating content. So it's no longer just ideas of the few, it's now ideas of many that's being distributed. And again, in our world, I think we're kind of on the cusp that more and more people are able to find answers for themselves, right? More and more brains are involved in looking at data and coming up with solutions and so on. Is that part of data literacy? Well, creation of content, I think, is. But what underpins all of this is those human traits that are just critical for this to work. Things like curiosity and critical thinking. This probably appears, these three words probably appear in every presentation I ever make. Because without that, the other stuff is actually not that useful. Because firstly, we've got to have this inkling to even ask a question, right? And then we need to kind of know that what question should I ask? And when I get an answer, should I trust this answer? I need to cast a critical eye on the answer and make sure that it's actually useful to me. So I think this is that human element is critical here. So let's look at some examples now. So I have a few questions sort of to myself, really. Like one would be, do you trust your data? Because I think that's where we need to start. We're going to start with the visualization. We need to start at the beginning with the data. So I have an example from a few years ago now. Remember when the Apple Watch came out? We went to Twitter and we collected some tweets around the time when it was released. We wanted to see the sentiment. Are people loving it? They're hating it? Any interesting things, any commentary they would have around this new device? So we collected 1.5 million tweets. There are some X's there, but they're not important. You don't need to worry about those. It's those numbers that are probably more important. Actually, the graphics are more important here. So looking at it over time, this is a month of data. It looks a little chaotic. We can change perspective again. And what you notice is that there's a big gap where we didn't collect any data at all. It's clearly some technical issue that prevented us from collecting this. At the end, the last sort of quarter, again, the numbers look pretty miserable there. Clearly, there was an issue. So at this point, we should say, well, this is actually useless, right? If I'm going to make any decisions based on this, my findings will probably be incorrect because the data is rubbish. But assume that we went on and continued looking at this. So I threw this up on the map. And you can see a whole lot of activity on the East Coast, the West Coast in the US, in the UK. I could drill down and look at more detail to see what people are saying around this topic. And this looks pretty good until I went and had a look how many of those tweets were actually geocoded. And 98.9% were not geocoded. So we're only looking at 1% of the data. So that's really would be quite deceiving if I was making any decisions based on that assumption, right? It's only 0.6% of the tweets are geocoded in the United States, for example, right? And then we looked at, so assume again that wasn't enough for me to give up. We then looked at the sentiment. So positive on the right, negative on the left. The big spike in the middle basically says no sentiment. There is nothing telling me whether they are happy or unhappy. I mean, from here you can kind of see the positive sort of outweighs the negative a little bit as well. And then you dig in a little bit deeper and you find that 72% of your data has nulls in it as well and so on. Now I'm showing you this because I think this is a critical part of understanding that your data that you're going to use is actually useful to you, right? We shouldn't just be taking it face value. Now, I used to do all of this in Tableau, but now with Tableau Prep, you can get a lot of that information right there, really early when you have that profile window. So how many of you, I should be asking this in reverse now, how many of you don't know about Makeover Monday? All right, there's 1, 2, 3 people. Okay, so for the 3 of you, okay, you should know about it by the end of this. So Makeover Monday, Eva Murray and Andy Kriebel, every week they go and hunt for some data-related or article that has some data component in it. And usually there's a visualization as part of that. And then they take the data and they publish it to the community and ask the community to, one, can you improve on those visualizations that were presented there? Can you maybe tell a different story that was in that article? And it's an absolutely brilliant way to learn and practice. So, you know, at the beginning you might just look at other people's work, but I would highly recommend that you go and have a go at using that data and creating your own content. Okay, so I went to Makeover Monday, and I picked up a data set around maternity leave in OECD countries, right? And this is what it looked like in that article. It was a table of numbers. And let me just explain the concept, what they're showing there. So maternity, this is paid maternity leave in OECD countries where we're basically being told how many weeks mothers would get and how much pay, or what percentage of their pay they would get over that time. Yeah? So this is, I mean, again, enough time and effort, I can kind of make some sense of it. There was a chart as well, which showed me they ranked the countries by the number of weeks they were getting. But if I had a slightly different question, I wanted to see, well, which ones are getting paid more than others and so on. It's static, I can't do anything with it. So I went and picked one example that was out, created by someone else. And this is what it looks like. So let me explain, because it looks a little complicated, but it's not really that complicated. On the x-axis is the number of weeks. And on the y-axis is the percentage of your pay. So for example, if I picked the UK and highlight that for you, you can see that for the first 13 weeks, you would get 100% of your pay, and then it drops down and you're getting a lower percentage. Yep? So it's pretty easy to understand what's going on there. Now I have a question for you, and I've got some things to give away here. And maybe you guys saw my tweet and you all came here because I was going to give things away. But I brought some goodies from Australia for you. So, but I'd like to let you think about. Actually, maybe I should tell you what I've got, and then I'll tell you what I. So I've got 2 things I brought, right? I got some Tim Tams, which is some of you might know, and I got some Vegemite, right? So both of them are brown, right? This one tastes like chocolate, and this one tastes like, are we recording this? You be the judge, right? So I'm going to ask you a question, and you can pick whichever one you want, and whoever comes second, you can have the other one, right? And whoever gets the Vegemite, I might have to give you a lesson so you don't overdose on the stuff. So my question for you is, this is a chart that, unfortunately, is now broken because, I'll tell you what I'm going to do. My titles have disappeared. That's not supposed to happen. The title of it is Maternity Leave in OECD Countries, right? So what's wrong with the data on this chart? Now, other than the United States being there at 0.0, but that's, I'm not here to judge. But can anybody else see if there is an issue with this data or this visualization? Not so much the graphics of it, but what it's showing us. Anyone? So so I should correct, right? There's a maternity leave, there's parental leave as well, okay? So sometimes you're absolutely right. If you put these together, the numbers look different. So those are kind of taken as separate things, yeah. And I agree with you. In fact, there was a gentleman from Sweden in a talk a few weeks ago that had the same comment. So I think the data is correct, but it's a subset of the whole picture, because I know you guys probably get 2 years or something just coming or, something crazy like that. But yeah, so good, well spotted, but no, that wasn't the answer. So anybody else? OECD countries, remember? Yes?
Kind of hard to see the lines.
Yeah, it's probably a projector more than anything. But so it's not the visuals of it. We're thinking data.
I'm confused by the percentage on the y-axis. So, like in the United States, does that mean like you don't have full days off? So if it's not 100%, it means you have a partial day off.
No. This is basically 0-0, right? This is by law, right? So obviously companies give you maternity leave and stuff, right? But by law, the governments don't pay you any money to stay at home. But that's not what it is. Anybody?
Did you show the count per population? Like what's the...
No, nothing to do with population. These are just, yep.
What's the logic between why some are labeled and some aren't?
Oh, that's just because there was not enough space. So Tableau was smart enough. Yes? Thank you. Yes, we got a winner at the back, right? Not all the countries are OECD countries. Thank you very much. See, this is a much smarter crowd than the one we had on Wednesday. I hope they're not recording this, right? They'll come hunt me down. All right, so you have a choice of one of these or the other, right? You take the choice, of course, yeah. All right, we'll give the other one away later. So if you look at this, the yellow lines, and again, my apologies, the projectors are not fantastic in this room, but hopefully you can see them. In fact, I could make it look a little bit better as well this way. These were non-OECD countries. Now, I got caught by this myself, only when I started looking a little bit more into it, and I said, hang on a second, I didn't realize there were that many OECD countries, and Bulgaria, seriously, no? OECD countries, these are like sort of the developed countries. I mean, there's probably a definition for it that I wouldn't want to make up on the spot right now, but it's mostly the more economic powers in the world that fit into sort of that developed space. So the point I wanted to make over here is that this should also be part of data literacy, right? Looking at these charts, making sure that the data is in fact true. Just because it was in a table in the article and we just took it and copied and pasted it without really thinking could have some consequences. So the first example was whether it's useful. This one is whether it's even correct. So my next question is, do you trust what you see? So again, looking at charts, but maybe trying to figure out how do they come up with the answers in that chart. So one example we will look, so this is something to warm us up now. School grades in the US. And here is my example now. So I'm looking at 3 schools over here. On the x-axis, you can see the size of the school. Number of students in the school or in the class or doing a subject or something. It doesn't really matter, but size of students. On the y-axis, it's your GPA score, which I had to go look up, but you guys should all know what that is, right? So you can see there are 2 schools up here that are pretty small. They're similar in size, and they have relatively high GPA scores. So if I go and select these 2, I now get 2 bar charts on the right. The one on the left was calculated using student numbers. So I would take, I don't know, say 150 students plus 100 students, add up their GPA scores, and then divide it by number of students, and I'm going to get that average. Or another way to do it, and that's the bar on the right, is I just take the 2 numbers, add them together, divide by 2, and I get the average of the averages. Right? They look very similar because the schools are very similar. But now if I was a politician, I've got that other school there, right? It's a bigger school, not that smart, right? What's going to make me look better? So if I go and select that guy and bring it into the picture, if I did it by students, meaning taking all those 700 students all together, adding their GPA scores and then dividing by the number of students, I'm going to get that pretty pretty low number of 2.97. If I, however, just took the three numbers, divided by 3, then I get to 3.4, which is much better. So clearly, I would be selling myself as a person for a particular district and how wonderful my schools are in that area, right? Now, there's nothing wrong with either of these calculations, right? This is not a fundamental error. But how often do you know which method they actually use to do this calculation? They should be telling you how they work this out, because if they don't, you might make sort of wrong assumptions, right? So it's fair to say that there should be an explanation around this. So, this is sort of talking about this concept of how was this data aggregated? And most of the data we look or we see in charts is aggregated, right? I mean, sometimes you might see some very complex scatter plots with individual values, but most of the time there's some kind of aggregation going on, and we need to be familiar with this. All right, so that was one example. Next one, which I'm sure you'll be all familiar with. I went looking at the starting income when you graduate from universities. Just by the way, when you go and get pictures for universities, they all tend to look the same, right? Like, it's just quite strange. This is University of Sydney, but you could be Oxford or something. It's just like all these pictures tend to seem the same. So I want to take you back to 1984. Again, some of you might be thinking this session is geared to the older audience, but that wasn't the intention. So I wanted to see what income you would make when you graduate from certain universities. The numbers are in today's terms, but it is 1984. So if I looked at, good old famous MIT, say it would be around 85,000. Now, don't worry about the numbers, exact numbers. I mean, this could be for a particular faculty, or could be for the whole university or subject. It doesn't really matter what you studied then. So if you bring in Stanford in here, and Harvey Mudd College is pretty good, Chicago State is a little bit lower, and then you pick on University of North Carolina, boom, and things just go kind of off the scale here. I'm thinking, well, if I was studying 1984, that's where I want to go, right? I'll be like killing it when I finish. So I'm sure many of you know why that number's so high. I told you guys were smarter than the other group, come on. There you go, because of this guy, right? And by the way, there's a great viz in the foyer about Michael Jordan that's really fantastic in one of the art section of Tableau down on the ground floor. It's a great example. You should check it out. And it's all because of him, because he obviously got this massive contract when he graduated. I think he majored in geography or something. So clearly that number is skewed because we took an average of it. The green bars are a median, which is a different way of calculating this, where we take the middle point. So of course, if I go and exclude Michael Jordan from this equation, then the median and the mean or the average look very similar again. Now, my apologies that the charts don't look perfect here. We had to make some quick adjustments before we jumped on here. Another way of looking at it is, if these are the distributions for the different universities, they all can't clump together, but over a larger scale here, and if I put Michael Jordan in there he is, right? And just a little aside, that's a logarithmic scale, right? Otherwise, it would have been like completely off the charts, okay? So that was pretty obvious, really, when you think about it more. So I think part of data literacy is the fact that we should all have some basic statistics. Again, we're not talking about data science here. We're not talking about you explaining p-values and the depth of some complex things. We're just looking at basic stuff. So I want to show you another example, actually, before we show the example, just to explain maybe what we just saw. So if you look at a distribution, there are some outliers in it. If you use median, it's a great way to hide inequalities. So whatever is in those outliers, it kind of drops off because the median is just the midpoint of all those data points. But if we use mean, like we did in that example with Michael Jordan now, it's going to skew those numbers towards something, which could be something good, like in this case, that 150,000 K after graduation looked pretty cool, right? Or could be something bad, right? So this is how these two operate. So these were quite obvious. So let's look at something that is maybe a little more subtle and maybe not as obvious on the surface. So I'm going to look at life expectancy now. And so I went and picked up some data from Sweden, just for a gentleman sitting here in the fifth row, right? The reason why I picked data from Sweden was because it goes all the way back, to 1751. It's kind of hard to get data in Australia going back that far for life expectancy. But what you see over here is that it'll start on the right. The average life expectancy these days is around 80 years, right? And most countries in the world, in sort of developed countries, will be somewhere around there. You can see through history there were a few little hiccups over here. Some diseases just wiped out whole populations there. But if we go back to 1751, it says that the average life expectancy was 38.4 years old. What does that mean? Does that mean that everybody died before they turned 40? Right? It was that like, you'd be some freak if you lived to my age, right, in those years? Well, on the surface, it looks like it, that people lived half as long. But when you think about it some more, you realize that child mortality and infant mortality was really, really high. So for you to make your first birthday was an achievement in itself. So if we exclude the time from birth to the first birthday, and we say if you survive to your first birthday, your average life expectancy bumped up by almost 10 years. If you made it to your fifth birthday, it's up to 54 years, and 10th birthday is a little bit higher. And that's almost 20 years more than what it was when we measure it from birth. So people didn't all die at 40 or 35. There were many people that lived to be 80 and 90 probably. I mean, generally I think we're probably living longer, but it's not that extreme difference that you could see here. And this is, again, all about using averages and those big volumes of numbers that were, in that 0 to 1 year bracket is skewing all those numbers for us. But maybe sometimes not as obvious to see, right? So that was the example. And the last few examples talk about, do I trust what I create? And, sometimes I could be doing things on purpose to mislead people and hide some of the complexity behind numbers and charts and persuade you that my view of the world is correct. Or sometimes it could just be a mistake, and we just need to keep asking ourselves, are we telling the truth here? Are we using the facts in the right way? So two examples, one around climate change, that's very topical, and cherry picking. And I picked it, there was an article written by Harrison Schmitt. Some of you might be familiar with him. He's an American geologist. He is a former senator, I think, in New Mexico. I think, from what I read, he is the last living person that walked on the moon. So clearly, I would think a man of science, right? And he wrote this article a few years ago where he said that the Greenland glaciers are actually advancing and getting larger over time, which is like, wow, that would be good news, I think, if it was true. So I went, being a data geek, looked up all the data around these ice sheets, and we're going to take a closer look. So let me see if I can. Oh. So a little bit of explanation here. First, we're looking at the monthly average of the Arctic sea ice extent. So what this is the ice sheets that are kind of growing into the ocean in wintertime, and then they're kind of receding when they melt in summertime, right? And we can measure all that, and it's in million square kilometers here. So if we take a look at, he specifically talked about these two dates. And in fact, in 2009, those ice sheets were bigger than in 1989. So that's true. And going a little more detail, it was true on a very specific date in April of those years, which is also true. But then when we expand the timeline, actually, just to give you the context, right, they're not that far apart. But if we look at the timeline and expand this to, 20, 30, 40 years, the trend is just clear to see, right? Yes, there are variations over that period, but the trend is definitely going down. So what happened here, we picked those 2 dates. That is like the only time in this entire data set that trend would be going upwards, right? And that's what that whole argument was based on, right? Which is an extreme example of cherry picking. Now, sometimes it might not be as obvious as this. It might be some biases that we have, and we pick the right data points to make a point, okay? So really, is that part of data literacy? Well, I think it is. It is, again, that ability to question things and verify and make sure that we're not using facts to mislead. Some of these ideas are quite complex. And just going to leave you with a quick animation here. I've got more stuff. I'm not leaving you for the day yet, don't worry. This is just looking over those 30 or 40 years. And again, that display isn't perfect, but the color goes from blue to red, which is actually years from 1979 to 2017. So the point is those lines are dropping down, meaning that the ice is definitely shrinking. So the final example, we're going to go back to World War II now. And during that time, you had the Army, you had the Navy, you had the Air Force fighting on the front lines. But there were a whole lot of smart people back at the office, still working on, solving some of the challenges during the war. And one of them they were asked about is, we've got all these planes that are obviously being shot down by the enemy fire. And here's an example of one that came back from the front line. And those white dots are bullet holes all over the plane. And they said, well, what could we do to make them a little more resilient? Where could we put some extra armor? And obviously, we can't, put like a tank armor on it. That has to be a bit of a give and take there. It has to be light enough for the thing to still fly. But where would you suggest we put more of that armor to protect them better? The very first thing you might think about is like, well, just put where the holes are, right? That would make sense. But then when you think about it a little bit more, you say, well, we actually have a very incomplete data set here. Because the planes that actually got shot down, they never came back to the labs to be examined, right? And they were probably shot through the engines or the cockpit and so on. In fact, not where the holes are. So we should be putting armor around the areas that have no holes, because that's probably where the fatal things will happen if they get shot there. Now that I told you, it kind of makes sense, right? It's quite obvious. Now, I know you probably don't. How many of you built planes? Yeah, 1, 2, couple. So, and probably most of you are not taking part in any war efforts. So I'm going to talk about something that's a little bit closer to home, which is you all care about money, I'm sure. So we're going to look at the same concept, but looking at money. So this idea is called survivorship, where we only look at things that have survived to that point, and we use that data set without considering the stuff that is left out. So the example here is that I have a proposition for you guys. I have an investment opportunity of a lifetime. The returns of my little portfolio were 23%. I mean, that's like ridiculously great, but it's much better than the interest rates that they are right now if you're keeping money in the bank. And my fund is made up of a whole lot of investments, whether they shares or other things in there. And the return for 12 months ending 2017 was 23%. And the way I calculated that, I basically took all of those investments at the end of that period, compared them to what they were at the beginning of the period, and that's my return over that time. But what I conveniently not telling you is that halfway through the year, I had some other investments in that fund that didn't really do so well, right? And if I include them in here, I can click on that button there, suddenly that return drops, well, to half of what we saw earlier. And this is a perfect example of that survivorship bias, where there is some data that is missing because I'm only using the investments that have survived the 12 months and comparing them to themselves at the beginning of that period, and I'm ignoring anything else that happened in between, right? So this is another example where sometimes being aware of the fact that there is some missing data that should be taken into account when we're looking at these numbers. Is that part of data literacy? Well, I think it's part of that critical thinking and asking these questions. Because sometimes they might not be spelled out anywhere. They won't be telling us how things are calculated, but we should probably be asking that. And when we, developing things and creating content and we are analyzing data, we should be keeping that in mind too. So how do we accelerate this process of learning data literacy and so on? Obviously, there's a lot of content through many, many programs out there online and face-to-face and so on. Tableau has recently partnered with an organization that will help develop, in partnership with Tableau, help develop a data literacy type of content. Because we do a great job at teaching you about Tableau, right? There are many courses there. We tell you where to click, where to drag, what colors to use, how to visualize things in the best possible ways. But this is a little bit more about how do you think about data? What things do you consider when you're doing data work? And sort of on my more sort of self-learning side, these are some of the books that I would highly recommend. I mean, Storytelling with Data is a fantastic overview, some great examples to get you into the data visualization side of things. Stephen Few takes you a little bit deeper and explains why we do things in a certain way to make it more accessible. And then Andy's big book of dashboards as well, which gives you examples of real-life dashboards and what others have done. So that's sort of on the one level of visualizing data, but there is also that sort of critical thinking element where you need to consider what is right or what is wrong or how you should communicate that. And the one from Alberto Cairo is a fantastic book, The Truthful Art, and then a few others there as well. So just to leave you with a few thoughts. So hopefully you would have seen that data literacy isn't just about visualizing charts or understanding charts, right? I think it's much broader than that. It's that kind of education of how we think about data that is necessary. And that is all about people. It's not about technology. It's not about data science. It is how we uncover that curiosity and the ability to say, I should be asking that question. I should be questioning these answers. And the reason for that is this is a new language that we all need to be fluent in. And it's important because currently I don't think the IT guys can talk to the data scientists, and data scientists can't really talk to the business guys and the domain experts. They don't have a common language. There's a lot of misunderstanding going on there. In fact, at the end of one of these presentations in Australia a few months ago, it was a different presentation, but also on data literacy, a lady came to me and she runs an organization that basically represents all the data scientists. And the data scientists were saying, we just have this brick wall. We come up with all this cool stuff, and then we get these blank faces when we start talking about it. Even when we have to dumb it down so much what we're actually doing, because there is no common language. So I think it's important that everyone at least has that right level of skill there. And of course, no presentation will be finished if in 2018 without talking about AI, right? And I think this is an exciting time around these smart machines or smart computers and programs and so on, because this will take away all the drudgery of the things that we hate doing. We'll probably automate all of those repetitive things and also do smart things. We'll probably tell us where to look. We'll probably highlight the things that are important. We'll find some insights that we should consider, and that's all cool stuff. But that will give us more time to do all those human things, to know that we should be asking a question, right? To know what kind of question to ask, to get these answers and then consider whether they are correct or valuable to us, right? So I think it will give us ability to do all those human things that we do so much better than machines do, at least today. Who knows? You know, in 15 years, this story might change a little bit. So this kind of brings me to the end. There's some details, Dave. You need to get in touch with me. I'm assuming you will all be filling out the survey. And we've got 4 minutes, but I might hang out here. Oh, someone has a question. You know, I've got some Vegemite to give away, by the way. So anyone that has a question can grab that. And I thank you very much for staying till the end of the conference. Thank you.